YouTube, this is Umozo3. In the previous lesson, we learned about another type of set that we have available to us, right? First, we talked about array lists and linked lists. Then we talked about stacks and queues. Then we talked about sets and maps. And then we talked about this thing called a vector, which sounded a lot like an array list. And then we talked about this thing called a concurrent linked queue, which sounded a lot like a queue. And then we talked about a linked hash set, which sounded a lot like a hash set. So we're going to be reviewing some of those more advanced data structures. But then in this video, we're going to learn about another type of dictionary that you have available to you. So we've already learned about two sets of key value pairs. In lesson 55, we learned about hash maps, and in lesson 64, we learned about hash tables. In this lesson 68, we're going to be learning about something called a linked hash map, which is a similar subclass of hash map, just like linked hash set is a similar subclass of hash set. But let's go ahead and review some of the things we talked about in the previous video. Let's review linked hash set first, and then I'll go back and review concurrent linked queues, which was talked about 2 videos ago. But we're going to go ahead and import some important classes, because we typically have to do that when we work with data structures and iterators and the collections class and the arrays class and the scanner class and file IO and all kinds of stuff that we need to import classes for. And then we're going to say in our main method, linked hash set of type integer, my set equals new linked hash set of type integer. And I already have the code output from when we ran this most recently, but we're going to say boolean q equals my set.add of 100. So that would assign q to true, and it would add 100 to the set because the set does not currently contain the element 100 when it's first created. But then if you say boolean r equals my set.add of 100, that would assign r to false because the 100 element is already in the set. So you can't add a non-unique element to a set. So then if we say q or r, that would be true. But then if we say system.out.println of q and r, that would be false because r is false. Then if we say system.out.println of my set.size, it would just have one unique element. And then if we remove 100, and then we could ask if the set's empty, and we would see true, it's empty. And then we could add 5 unique elements, 5 unique integer objects to the linked hash set. And then we could say iterator of type integer k equals my set.iterator and u equals 0, while k.hasNext or false, system.out.println of k.next. If u equals 0, k.remove, u plus equals 1. So that would only remove the first element that's being referenced, that's being called by the iterator. And then you say system.out.println of size of linked hash set, and then my set.size, then you would just have 4 unique elements in the set after you used the iterator to remove one of them. And then you say my set.clear, you can remove all elements from a linked hash set or from a hash set more generally by calling the clear method. And it's a void method, it doesn't return anything. You just call it and it removes all elements from the linked hash set. And then you could say system.out.println of my set.isEmpty, and it would return true. So hopefully that's pretty straightforward for you. It's just hash set all over again, basically. It's just a subclass of hash set. So if you have methods and functions available to you in hash set, if you're already familiar with how hash set works, it shouldn't be that big of a jump to understand how the linked hash set works. And then we also studied this class called a concurrent linked queue, okay? And so we were talking about concurrent linked queues. And so it's actually a class. So we said that queue is just an interface. And that's why when we create an ordinary queue, we have to declare it as a queue, but initialize it as a linked list because queue is abstract. Queue is an interface. You can't create a queue. You can only declare it as a queue and initialize it as a linked list. But with concurrent linked queue, it's actually a class. So you're going to declare and initialize it as a concurrent linked queue. And we saw how you would do that. So you would say import java.util.concurrent linked queue. And then what you would do is you would basically say, you would have to type it all the way out. And then just to save time, I could go ahead and copy paste it. So you could say concurrent linked queue and then I guess you would need a data type. So you could say double my queue equals new concurrent linked queue, long name of type double. And then you have empty parentheses because you're calling the default constructor of the concurrent linked queue class. And then you can go ahead and add elements, right? I think we saw enough of examples of this in a previous video, but we can say my queue.add of 8.8, and it's okay for elements to be duplicates, right? My queue.add of 2.5. And then what if you say system.out.println of my queue.pull? Okay, so basically this returns and removes the 16.2 because that's that at the front of the concurrent linked queue when we call poll. Okay, and then what we could do is we could think about the size of the queue after we go ahead and remove that element. So we could say system.out.println of myDictionary.size, right? And so we would just want to make sure that there are only 3 elements rather than 4 elements in the queue after we call the poll method, right? But this is just like queues. The only difference is now we're talking specifically about a concurrent linked queue. And if you're more curious about exactly what that is, you can go to the API and learn about it yourself. But then we can think about this code output. I think I'm repeating a lot of the things from the previous example, so I guess we can just probably look at these 2 lines here. But it would just go ahead and give us that 16.2, and you could convert it to an int if you want. So you could say int of myQ.poll, and then you could say system.out.println of myQ.size, and then there would just be 3 elements in the queue after you removed the 16.2. What if we wanted to iterate through it? So we said that with queues, you only have an iterator, right? We've been talking about how with array lists and linked lists, you get an iterator and a list iterator, but not an enumeration. With stacks, you get all 3. With queues, you only get an iterator. With sets, you only get an iterator. With hash maps, you get a couple of different things, right? You can do an iterator on the keys or an iterator on the values. And then with either hash table or hash map, you can also call dot elements on it and it would return an enumeration. I think that's for the hash table, right? So that was actually one thing that we said might actually be better about the deprecated class. Like one thing that might actually be better about a hash table than a hash map is that it has this elements methods that you could do an enumeration on it. But that's really not that big of a deal because the enumeration class kind of sucks. The method names are long and there's no remove method. There's really not that much functionality in an enumeration that you wouldn't see in the iterator, let alone in the list iterator. So then anyway, hopefully that's clear to you, but we're just going to say iterator of type, it would be of type double, right? And then you could say, let's call it hot dog. Just call it something random. And then we could say myQ.iterator. Okay, so this is just how you create an iterator. Okay, and you could say while hot dog.has next. Okay, and then what you could do is you could basically say, you could say something like int u equals, and then what if we want to do myQ.next.int value, and then we could say system.out.println of u plus 4. So let's think about what this would do. We know that in the double class, there's a method called int value, and it's an instance method. So you call it on a particular instance of the double class. You call it on a particular double. Okay, and the elements in this queue, in this concurrent linked queue, are certainly doubles. And so we can go ahead and remind us of how the int value method works, right? But you go ahead and go to double Java API. And there's a method called int value. And so if you call it on a double object, it would return the integer value. So you would go ahead and go down here to int value, and it says it returns the value of this double as an int. Okay, and so you can go ahead and learn about that. But basically, what would you get here? So it wouldn't be myQ.next, it would be hotdog.next, right? You call .next or .has next not on the data structure, but on the iterator. So you say int u equals hotdog.next.int value system.out.println of u plus 4. So I guess we removed the 16.2 already. So there's only 3 elements in the concurrent linked queue. So if we do 8.8, well, the int value of that would just be 8. So 8 plus 4 is 12. Same thing for this other 8.8. It would just be 8 plus 4 is 12. Okay, what about 2 plus 4? That would be 6. So you would just be looking at 12, 12, and 6. And then we can probably just go ahead and delete this linked hash set example so that it's not confusing. But then we can go ahead and run it, run the main method. And so let's think about these numbers that we got here. So we pulled, right? We pulled the front of the queue. So that was the 16.2. And then we got the size of the queue. So there are only 3 elements in it. And then we got the 12, 12, 6, as we discussed just now. What we're going to do in this video is talk about a linked hash map. Okay, so that basically we've already learned about, so now there are going to be 3 types of dictionaries. Okay, so there's a hash map, which was studied in lesson 55. There's a hash table, which was studied in lesson 64. And now we're going to think about a linked hash map, which is being studied in lesson 68. So what we're going to do is we're going to learn about another way to have dictionary, another way to have a set of key value pairs, right? So in a dictionary, we know the keys in a dictionary have to be unique, but the values in a dictionary don't have to be unique. But anyway, we can go ahead and study linked hash map. Okay, linked hash map. And so just like we had a linked hash set, which was a subclass of hash set, we have a class called linked hash map, which is a subclass of hash map. And so here you can see that here, right? Object is the superclass, and then one down is abstract map. And then one down from that is hash map, and then one down from that is just linked hash map. So just like if you're already familiar with the methods of hash set, it's not that hard to use a linked hash set. Similarly, if you're already familiar with the methods of hash map, it's not that hard to go use a linked hash map. But it says it's a linked list implementation of the map interface, okay? It differs from the hash map in that it maintains a doubly linked list, okay? It's similar as what we saw with hash set and linked hash set, but you don't really have to worry so much about those implementation details. But just that if you scroll down here, we have a lot of the similar methods that we had available with a hash map. So we can put key value pairs into the dictionary. We can get a value associated with a particular key if we pass in that key as an input. We can return a collection of all the values in the linked hash map. Okay, we can clear the linked hash map. We can remove an element from the linked hash map. We can see if the linked hash map contains a key. We can see if the linked hash map does other things, right? So there's all these kinds of methods that are being inherited from the superclasses, okay? But then there's also overridden or for the first time defined methods in this subclass. But anyway, let's go ahead and think about what we're going to do here. So we need to go ahead and import another class. So you need to say import java.util.linkedHashMap, okay? And then you're going to say linked hash map. So now it's not just hash map, it's linked hash map. And again, you need to pass in two data types because one of them is for the keys and the other one is for the values. So let's do integer and double, okay? So then we're just going to say myDictionary equals new linked hash map. Very similar to a hash map, kind of similar to a hash table, maybe slightly less so. But all three of these data structures do basically the same thing. So you can say myDictionary.put of 0. What double do we want to assign to 0? Let's do 66.2. And then you could say myDictionary.put of 2, and then we could say 81.01. And then myDictionary.put of 3, 94.5, and then we can say myDictionary.put of -8 with 15.5. It just maps integers to doubles, right? You get integers on the left, doubles on the right, keys on the left, doubles on the right, and then you say myDictionary. Let's just do one more of 10 with 15.5 because we said the keys in a dictionary have to be unique. The keys in a linked hash map or a hash table have to be unique, but the values in a linked hash map or a hash table do not have to be unique. So what we're going to do is we're going to say basically we could go ahead and think about an iterator. Okay, so it turns out that we're actually going to receive the key set method, right? So the key set we can still call iterator on the key set or on the values. So let's do an iterator on the keys. Okay, so we're going to do iterator of type integer my keys, and then you could basically say myDictionary.keyset. Okay, so hopefully that makes sense to you. And then it would be myDictionary.keyset.iterator, right? myDictionary.keyset.iterator. Okay, and then what we're going to do is we're going to say while myKeys.hasNext. Okay, and then you can say something along the lines of system.out.println of what if you said something like this? What if you said myDictionary.get of myKeys.next? So let's think about what this would do. So basically we know that the get method, we've already talked about how that works with a hash map and a hash table, and we can learn about it here. So it returns the value to which the specified key is mapped. It's like putting in an input and getting an input out, so get. Okay, so we're going to say system.out.println of myDictionary.get of myKeys.next, because myKeys.next, this is just going to be each of the keys in the dictionary. So if you say myDictionary.get of key, it's going to return the value associated with that key. So this is actually going to iterate through the values in the dictionary, okay? Because even though the iterator is being called on the keys, we're going to say for each of those keys, myDictionary.get of key. And then so that would return a value. It says it returns a value right here in the API. So then we can go ahead and compile it, and then we can go ahead and run it. and think about what we get here. So we get 66.2, 81.01, 94.5, 15.5, 15.5, okay? So hopefully that's clear to you how that works. And okay, what if we just said myKeys.next? Well, then we would just get we would just go ahead and get the 4 unique keys. We would get the five unique keys in the linked hash map. So you just get 0, 2, 3, -8, and 10. So hopefully that's clear to you. And then we also said that we can go ahead and replace, we talked a little bit about these replace methods, right? And it turns out that a linked hash map doesn't have its own replace method, but it's inherited from the hash map superclass, which we talked about 13 videos ago. And so you can go ahead and remind yourself of how the replace method works. So you'd have to go back and click on the superclass. So you'd have to, now we're back in hash map, like we talked about previously. But remember that with a hash map, if you say replace, if you just stick in a key and a value, it's going to reassign the value associated with that key to whatever you stick in. But then there's other types of replace methods, right? There's another one where it accepts 3 values and it only assigns the new value to the key if the old value is what you said it was. So let's just try 2 examples. So we could say myDictionary.replace of 2 with 22.2. 2 with 22.222. And then what if we say myDictionary.replace of 10, 17.5, 19.5. So this only reassigns the value associated with key 10 to 19.5 if the current value is 17.5. And that works with hash maps, hash tables, and linked hash maps. Okay, and so we can go ahead and think about, well, the keys are going to be the same, right? So the output wouldn't be any different now. If you're just replacing values, the keys don't change, right? If you don't add or remove key value pairs, then all the keys are going to be the exact same. But what we replaced is some of the values. So then what we're going to do, let's go back to our original implementation. So myDictionary.get of myKeys.next. Okay, and so then what we're going to do is we're going to go ahead and compile it and run it. And then we get 66.2, 22.222, 94.5, 15.5, and 15.5. And you can see that the value associated with the key 10 was not replaced because the current value was not 17.5, but if it's 15.5, so now we just do a quick adjustment to the code, then the value in the linked hash map updates from 15.5 to 19.5. So hopefully this makes sense to you, and we can do different examples here, but if you're familiar with a hash map and a hash table, which we brought up not too long ago, it's not that big of a jump in understanding to think about a linked hash map. It's just a direct subclass of hash map. And it has basically all of the same functionality available to it. You can clear a linked hash map. You can go ahead and see if the linked hash map contains a key. So I think that's maybe something we could do in this video, right? But what if we say something like system.out.println of myDictionary.contains value of 94.5. Okay, and so then hopefully that would output a true Boolean. Okay, so that's just showing you how the contains value method works. And if you're unclear about how these methods work, or you're curious about new ones, it just amounts to a quick Blackle search and to go to the API and learn about it yourself. Okay, and then we can also think about, what if we say myDictionary.contains key of a -11? So I guess, is that one of the keys in the dictionary? So no, it's not. So then that would go ahead and return false. Okay, what if we said myDictionary.contains value of 15.5? Okay, so we're going to say, does my dictionary contain the value 15.5? Well, we replaced one of the 15.5s, but there's still one. Okay, so we replaced one of the 15.5 values, but the values don't have to be unique in a dictionary. So we still have a 15.5 left. And so this method call should still output true. Okay, so hopefully that's clear to you. But then if we go ahead and call the remove method, so we can learn about the remove method, which actually comes from the superclass. It comes from hash map, but then linked hash map gets it because linked hash map is a subclass. But you call remove on a particular key and it removes the value, it removes the key value pair. So then what if we say myDictionary.remove of -8? So we're going to remove the key value pair associated with the key -8. Okay, and then are we going to contain 15.5? No, because we removed one of the 15.5s and then we replaced the other. So this is just demonstrating some of the methods that are available to hash maps, and more specifically linked hash maps. So then if you go ahead and run it, you get false. Okay, you get false because 15.5 is no longer a value in the linked hash map. So hopefully that's another interesting data structure for you. We'll talk more about it in the next video. From UMills03, thanks for watching and please subscribe.